building smarter means building for this kind of changing world. And it's going to get at this issue of structural resilience in mitigating climate change. It's affecting insurance rates, and insurance rates are affecting affordability and becoming a huge issue.
But why are we going to talk about passive house when you came to hear about resilience? Why do people come to passive house? It's insanely comfortable. It's incredibly quiet. It's healthy, and as for our talk today, it's resilient.
So it's not just withstanding that first storm or that first wind event, it's in having that ability to recover from that as well too. We don't want to be designing to just the stressors that we're seeing today. We really have to think 20, 30 years out.
We have two amazing presenters for you today, and kind of a different approach. And it's going to get at this issue of structural resilience and mitigating climate change. This is something that I've spoken about a lot, and I think what builders are starting to begin to understand is that building smarter means building for this kind of changing world. We're seeing fire risk in communities that have never experienced fire risk before. Places like Hawaii, that's literally a rainforest, where we destroyed 2,000 buildings. Denver suburbs, where a Chuck E. Cheese and a Home Depot burned to the ground. These were not, in heavily forested areas. These were in the plains of Denver, where a raging wildfire destroyed over 1,000 structures, both commercial and residential. We had fires in Eaton, Pennsylvania, and the Palisades. We had fires on Long Island. In places we've never seen large destructive fires. And there's a real focus now on how do you create fire safety. It goes beyond the focus on fire safety. It's affecting insurance rates. And insurance rates are affecting affordability and becoming a huge issue. I talked to an attendee yesterday that just got their insurance bill. Their insurance bill is $9,800. You think about that, that's $800 a month. And that's a good part of a mortgage, and you're not paying the mortgage. This is just insurance. We've got to start to think about how do we potentially build new homes so that it's a completely different insurance category. If you have a home that is flood resistant or wind resistant or fire resistant, my insurance bill is $2,500 and my neighbor's insurance bill is $7,000, so that it makes new homes more, potentially more affordable. We have the same issue with respect to heavy rain, wind, and flood events. It used to be those were hurricane related or tornado alley related, but now we're seeing huge flood events from hurricanes in, Western Carolinas, in Eastern Tennessee, whereas these hurricanes are stronger, last longer, these events in areas that we haven't seen before. And the effect on insurance is pretty catastrophic. Insurance companies are pulling out, insurance companies are increasing rates. You look at the average insurance rate here in Florida, you're talking about $4,000, $5,000, $6,000, $7,000 is the average insurance cost. And these homes in these areas, in many cases, average $400,000 a year. So you're talking about a huge amount of your mortgage payment going to insurance. So we got to lean into resilience. We got to figure out how we build those homes. Got two fabulous speakers here, and I am with no weight gonna slide this all the way over. And Darren is going to take it away. Darren is from Wythe Windows, but he is going to give us a course that you teach for AIA
About passive house.
All right.
And so, but why are we going to talk about passive house when you came to hear about resilience? Well, one of the best ways to get to resilience is building through the methodologies of passive house. What are we looking for when we're looking for a resilient building? We're looking for a building that would allow people to shelter in place. When power is lost, the people are not going to be immediately uncomfortable. Well, passive house delivers all those things. And so you may ask yourself also, why is Darren, CEO and co-founder of Wythe Windows, talking about passive house? Well, actually, I got into windows because of passive house. I was a builder, like many of you here in this room. I built New Jersey's very first certified passive house. And when I was doing that, I had to bring my windows in from Europe. And I said, that completely stinks. How are we going to build more of these high-performing buildings if one of the key components is coming from overseas? And
they're very expensive, hard. We're paying import taxes and everything else.
Well, definitely now.
Now they're unaffordable.
Yeah. I finished my passive house and said, I need to make a factory to make these windows. And so we started in 2017 with a small semi-automated factory. And now today we have fully automated production lines, 3 of them in New Jersey, shipping coast to coast. I also sit on the board of directors for the Passive House Network, which is a national organization advocating for passive house and educating people about passive house, offering classes like this one, but also offering more classes if you want to become a certified passive house designer or consultant. And there it is. That's New Jersey's first certified passive house. That's my house, taken on a cold winter morning with my iPhone. So not a great shot, but gives you an idea. And our goal when we started the factory was can we get more of these high performing components into more homes and make them affordable for everyone. And actually what we do most of at our factory in New Jersey is not passive house stuff. It's actually people who are implementing passive house principles into normal buildings. And a lot of what we do is in affordable housing. We have tens of thousands of windows with the New York City Housing Authority. Why do people come to passive house? It's insanely comfortable. It's incredibly quiet. It's healthy. And for our talk today, it's resilient. It's affordable to operate and it's affordable to build. Resilience. We saw right here in Texas, that cold snap. Several people died. The fires out west. Some of the only buildings that survived were buildings built to the passive house standard because they were airtight, because those embers weren't getting in through the ventilated eaves, and because the windows were high performing, they didn't have that thermal stress. So it's a balancing act. How does this work? So just like if you were cooking a meal, you didn't add any salt to it, it wouldn't be very flavorful. But if you added too much salt, well, it wouldn't taste very good. So we take the principles of passive house and we balance them out to make the building very, very energy efficient, to minimize the loads down to its most reasonable level, and then add active heating and cooling. This slide is the most important slide. And after this, you could have your fruit cups and ignore the rest of what I'm saying. You got the 5 basic principles of passive house. Super airtight envelope. So you're going to create an air barrier that goes all the way continuously around the building. Separately, you're going to also have a super insulated envelope that is continuous. So you're going to insulate the building all the way around. You're also going to have a thermal bridge free design. If we're just insulating wall cavities and then leaving the studs not insulated on the outside, well, each one of those studs is a thermal bridge.
So there's multiple techniques for that, right? We got SIPs, which is a completely different insulated foam structures and blah, 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 blah. Then you have staggered stud designs, right? Which, for deeper wall penetrations. Then you've got exterior insulation outside of the stud, which puts the studs on the inside of the envelope of the insulated. So any of those would be passive homes.
Right. Passive house doesn't tell you how to build your building, doesn't tell you what materials to use. It just says, hey, let's reach these targets of making the building airtight, super insulating the building based on the climate that you're in.
And no thermal bridging.
And no thermal bridging. And then once you have all that, well, now you have an airtight building with all this insulation.
Now you need an ERV.
Exactly. Yeah, old-time builders say to me, oh, well, the house needs to breathe. I'm like, yeah, well, you know what? The people in the house want to breathe too. They need fresh air, and you need to extract that stale air. But you don't want to just dump that out. So you have an ERV with heat recovery. Passive house doesn't say, oh, you have to have a centralized or decentralized. It just says, we need mechanical ventilation with heat recovery. Okay, so airtight envelope, super insulated, thermal bridge-free, ERV. My favorite one, high-performing windows. And that would give you up to a 90% reduction in your heating and cooling load. So you saw my house earlier. That's heated with a 2-ton mini split. That's over 5,000 square feet.
Well, you've probably seen these videos, all this YouTube stuff about the super high performance builders in Canada that build homes in Canada, way north, and they don't put a heating system in the home at all.
Yeah.
They heat with incandescent light bulbs. That's the only heat source in their home. I mean, it's you look at how they do it, and it's kind of all of the characteristics that you just talked about, but to the extreme. I mean, they got 1 foot of insulation on the outside of the studs, and all this kind. But it is remarkable what you can achieve if you really put your mind to it.
Well, I just forwarded a few slides over because it leads me to, where did passive house come from? Well, Wolfgang Weiss in Darmstadt, Germany, a physicist, he put the metrics around passive house. People have been doing these types of buildings for years. He just put parameters around these targets, these goals. And so if you talk about Canada, I mean, one of the leaders was Harold Orr with the Saskatchewan house that was built in the mid-70s, or the Locale house in Champaign-Urbana. But the Fram, the boat up there on the right, is a boat that went to the Arctic. and it used triple glazed windows, super insulated, and that was like in the 1800s or the early 1900s. It can be any type of building. You know, we say house, but house is really the word for building in Germany. It can be institutional buildings, it could be affordable housing, it could be multifamily, it could be hospitals, it could be schools.
You just showed that kind of curtain glass. How do they insulate? You know, your principles are insulate
Right.
outside of that. What are they doing?
That is a high performing curtain wall system with a thermally broken frame. So
Okay.
it's aluminum like a normal curtain wall, but it has a gigantic polyamide thermal break in there.
So they're adhering to the principles,
Absolutely.
even though I look at that and go, that's a disaster, right? You got glass on metal and, you know.
You would think, oh, well, the bigger buildings are more complex, they're harder to do. Well, no, actually, the bigger the building is, the easier it is to get to the passive
Because you're
house
just
standard.
repeating the same.
Well, you're taking advantage of the surface to air volume ratio. So when you have a smaller building, you have more surface area of the building envelope and less air volume. And the air holds the temperature inside the building. So if you have a bigger building with more air volume, like an office tower, it's easier to reach passive house standard. And it can be retrofitted. Here's that historic hotel in Connecticut that was retrofitted to the passive house standard. It's putting you back in the driver's seat of the type of buildings that you want to build. You know, so we're not going to become beholden to these mechanical designs. It's letting the designers be able to be empowered. The very first passive house, Wolfgang Feist still lives in this building in Darmstadt. And as I was saying earlier, he put definable targets. And once you have those targets, you have something to drive to. And you have to model that. And we use the passive house planning package to do that.
It's kind of interesting because if you follow German engineering, this is a very German engineering approach to almost any problems that they have, right? Which is follow the physics. Because you go back to your previous chart, you start with what's the energy loss. And of course, whatever energy loss you have to have energy gain.
And we see that in our buildings today. Like when you go to a window, what do you see next to the window? You see a radiator, heating and cooling to heat up the losses from those windows.
Yes. You see the exact same charts. I started my career in the auto industry. You see these exact same theory
Mm,
in auto design
mm,
because it's about mass and friction.
mm.
And,
Yeah.
and wind drag, right?
Yeah.
And it's the same thing. If you take mass friction and wind drag out, then you need smaller engines and less horsepower and less torque. It's
Right.
exactly the same approach because it's a physics problem.
You have these other standards, LEED, which is a fine standard. It takes a lot of interesting things into account, like siting of the building and let's say brownfield development or how close you are to public transportation. But it doesn't necessarily go to the core of what me and others in the passive house community are really most concerned about, that, and that's the operational carbon of buildings. And so you wind up with a lot of different results on how those buildings operate. Passive house is a tool that can be used in your net zero building or your LEED building or whatever other standard that you're looking for. It's a tool. If you're looking to be a resilient building, passive house is the tool that's going to get you there. And you're saying to yourself, well, Darren, this sounds nice, but this is a vanity project for the wealthy. No, actually, the Pennsylvania Housing Authority did a huge study and tracked many of their projects. And passive house, actually, it was cost comparable. Actually, it came out slightly less, $2 less a square foot. So it's showing us that it's not the passive house portion of the construction that's driving up costs. It's other decisions that we're making.
I also think this is a paradigm as an industry that we have to address, which is the paradigm in the industry is the most efficient homes, the homes with the most building science are luxury homes.
Yeah.
But the reality is the people that really need passive design and effective design are the poorest people in our society because they don't have the disposable income to pay for the utilities. You know, and it was interesting. I was talking to Kevin Clayton of Clayton Homes, and they just adopted a 100% heat pump water heater standard, which is really interesting.
Right.
This is for sub $100,000 mobile homes, and he's going, we're doing 100% heat pump water heaters. And I kind of said, I congratulate him. Said that's really awesome. He says, yeah, we did it because they deserve it.
Yeah.
He says those are the people in society that need that benefit the most.
I just wanted to reinforce what you were saying too, because what inspires me every single day is that we are making these windows affordable for people. And most of what I do, actually, believe it or not, isn't affordable housing. The same windows I put into a well-known movie star's home is in the South Bronx of New York City, in an affordable housing next to the Cross Bronx Expressway. And you are insanely right that the moment these windows are installed, and it sounds corny, but it makes a difference in the quality of lives of the people who occupy those buildings, because
Less noise,
less
more
noise.
comfortable environment,
Yeah.
and lower utility bills.
So insulation, wrap that whole building in insulation, not just the easy parts, the whole thing. Keep it continuous, super insulate the building.
There's a neat product at IBS last year that I had the opportunity for the NHB to present the 50 most innovative products at IBS, and there's this product that is an external plastic device you screw to the structure,
Mm.
and then you spray foam,
Mm-hmm.
and then you put your siding over that, and it allows that thermal break, but it makes providing that kind of uninterrupted thermal envelope around a structure, either in retrofit, because you can put it over an existing building, or you can put it right on stud.
People often come to me and say, "Oh, what's the best way to do this?" And I say, "Well, what's the way you like to work?" Because I mean, I can give you a detail that I know is going to perform, but if you're not a person that likes to work with tapes and you like to work with sealants, or if you don't like to work with spray foam and you like to work with blown-in cellulose, the best detail is the one that's going to be effectively installed. Thermal bridge-free design, we discussed that. Places where you're going to lose just a ton of energy, and it's going to create hazards for the building. And there's two types of thermal bridges, right? There's linear thermal bridges. Really want to try avoid those. Those are the ones that just go on and on and on. Let's say your foundation wall and the sill plate. Point thermal bridges, also something to be concerned about, but can be modeled and say, okay, I can live with that. And look at these thermal bridges. Wow, they're pretty, but they are also quite horrible. All the heat inside that house, all the work we did to create that energy, now we're losing it through the structure. There's simple ways to just create thermal breaks. Here, they're going to use a porous concrete, and it creates a little bit of a thermal break. And you can see on the right-hand side how the isotherms are more in line. Airtight, and talking about resilience, airtight means smoke tight. You mentioned in your opening, the fires in New Jersey. They affected us. I was in my passive house. We saw the smoke. You go outside, it was hard to breathe. I was comfortable inside my passive house. Same like the insulation layer, 100% continuous. You know how these two great things go together very nicely, but they're less effective separately. A windbreaker and a fleece. This is also a great demonstration for thermal bridges. Ooh, yes, what you've all been waiting for. So high-performing windows, and they're typically tilt-turn windows. Why tilt-turn windows? Well, tilt-turn windows were originally designed as a high-security window, but one of the side effects was, holy smokes, when we put locking points all around a window, we make it airtight. My tilt-turn window, let's say it's like a 2x3 tilt-turn window, it could have 7 locking points on it. If that was a double hung window, maybe you'd have 1 or 2. If it was a casement, you'd have maybe 1 or 2. Tilt turn, and ours is steel reinforced, 2 millimeters U-channel steel. Every window is an AW60 rated window. So whether we're making it for a single family home or a high-rise multifamily building, 20 stories high, you're still getting this incredible structure. Multi-gasketed, 1, 2, 3 gaskets, and the gaskets are co-extruded, so they're welded in the corners for continuous air tightness and water tightness. And this middle gasket is creating a dam, which is really nice. If anything got past this one here, it would hit this wall and then go out the weep holes on the front. And we make sliding doors, entry doors, balcony doors. How does it achieve these great values? Why is it so beefy? All these chambers here. And what are these honeycombs doing? Well, it's just like insulation. The fluffy stuff in insulation. It's not the rock wool itself that's insulative. It's the air. It's the gap. It's the space between the material that's insulated. It's beefy like this, and it allows us to, get that steel U-channel in there. It's so structurally, it's a steel window with this blanket of UPVC around it, and it gives you a wide glazing pocket to allow for a true triple pane IGU. So you see traditional manufacturers trying to stick a triple pane into a smaller glazing pocket. Well, it's not the 3 panes of glass that are making it insulative. So you really need at least 12 to 14 millimeters between the 2 paints to actually get some thermal performance. And this shows the difference in the thermal performance, just like the thermal bridging. And you can strategize the heat you take on in the summer and maximize the heat you take on in the winter. So in the wintertime, the the sun is lower in the sky, and you can use deciduous trees or shading mechanisms like this to have the house be heated up by the sun. And then in the summer, when the sun is higher in the sky, it hits the shading device and then casts a shadow on the glass. This is a centralized unit for a single family home. They also have huge rooftop units for multifamily buildings, or decentralized units that we're actually developing a localized ERV to go into our window, so that when we do affordable housing, they can now meet ASHRAE 62.2 without having to punch a whole new hole in their building envelope. What is the ERV doing? We're taking out all the stale air. We're bringing in the fresh air, and we're not going to just toss out that air. So let's say, it's 0 degrees outside. You can have an ERV with, 80% or higher heat recovery. So you can imagine that it's going to bring up that temperature dramatically, just passively, just by passing counterflowing the air streams across each other. As we were talking about earlier, heat runs to cold, and so it's going to transfer its energy, and then now that incoming stream we've passively heated up that incoming stream, and now your delta between your design temperature and what's being delivered into the house is so small, it can be made up with a very small heating and cooling system. So there you have it, the 5 principles of Passive House.
Well, we're going to hear from CertainTeed next, and they're going to talk about some of the material components that we can add, not just to windows, but a whole complete Passive House is about roofing, insulation, siding, right? We have all those other kind of modules, so we're going to talk. So pass it over.
Been with CertainTeed just over 13 years. I'm primarily on the residential roofing side of the business. I've had this passion for the construction industry, just growing up working on my dad's job site, learning a little bit about framing and plumbing and all that kind of stuff. I've spent a lot of time at CertainTeed on their engineering side, product development, really talking about this word resilience that we're hearing every single day. Looking at what are some of these environmental hazards that the industry is starting to see on a day in and day out basis, looking at some of those trends and how that's affecting our industry. So I'm going to talk a little bit more on what are different types of solutions that we can implement going forward. So what is resilience? So we hear this word all the time now. First thing that comes to mind is the word durability, right? And what kind of takes it to the next level is this ability to recover from events. Our buildings and structures are being put at higher and higher risk and stresses on an everyday basis. So it's not just withstanding that first storm or that first wind event, it's in having that ability to recover from that as well too. From an occupant standpoint, right, their primary goal is they want to have a safe home, and they also want to have something that's going to help them save money. We've done kind of a market sizing and trying to identify what is this resilient market sizing overall. We broke this out into both the roofing industry, siding and cladding, and then the foundational waterproofing. From a resilient standpoint, the siding industry does a pretty good job. There are a lot of products and systems out there. On the roofing side, there is a very large area for us to be growing. And on the foundation waterproofing side, some of these products are employed. On the residential side, there's a really big area for growth on this as we incorporate it into our home design. So from an environmental hazard standpoint, right, we all think about thunderstorms or severe convective storms, hurricanes, wildfires. We're trying to map out where that future potential risk is, right? So when we think about building the design today, right, we have to be thinking 20, 30 years out in the future. So what are those homes going to be experiencing in those future years? And how can we incorporate that thought process into the design today to make them more resilient in the future? So you look at wind speed, so that top left map there, right? It's not just the fact that the South Atlantic and Southeast are going to experience more hurricanes. It's the fact that areas more inland are going to now start to experience some of those effects from heavy rainfall, high winds.
It's really weird when you start studying these maps, right? Because everybody is starting to really map out where is the risk and from what. And Texas is high fire risk.
Yep.
And you'd sit there and go, really? How's, there's not massive forests, there is East Texas, but, not generally. But there are forests. They tend to be extremely dry because of the heat profile. And then we get massive winds. So we get these northern winds, where suddenly we'll start to fuel the fires. And like Austin, San Antonio, that whole corridor is actually one of the highest fire danger areas in the nation. So when you start mapping, again, temperature profiles, humidity indexes, and winds, you start to find areas where you go, my gosh, nobody's built for that.
As you look on some of these other maps too, so from a hail risk index, right? So the Midwest is no strength to
Notorious.
hail, right? So it's not just the fact that they're going to experience those hail events, but higher severity, higher frequency, but also we're building more homes in higher densities, right? So even if it was the same number of storms, same severity last year, just having a larger number and higher density of homes is going to continue to push those claims and losses up. And the last two maps on the bottom right, so from a flood risk standpoint, that's projected to really increase along the whole southern and eastern seaboard as well as the northwest. And then as Tim said, so the fire map in the bottom right, it's really that wildland urban interface area, right? So that area where our residential homes start to meet.
Where we want to live.
Exactly,
Right.
exactly.
That's
Away from people. And we then mapped these hazards looking at high and very high risk homes in these regions. Don't just look at the singular bars in the region that this, look at the areas where there's high convergence across that, right? So are there specific zones that are going to be experiencing a multitude of these environmental hazards?
As a builder, that's kind of useful if you're saying, look, I build in, whether Bethesda, Maryland, right? If you could create that bar chart from Bethesda, Maryland,
Correct.
then it would give you a strategy to sit here and go, look, these are my largest, environmental impacts. How do I architect my home? What materials do I select, right, in order to be resilient against my microclimate risk?
Yes, because it's not a one size fit all, right? Because there is a cost to some of this, right? And we have to stay profitable, but how can you be prescriptive in the areas that you guys operate in and pick and choose which type of systems are going to be best for your end users? So lastly, what we finally did was we also have a lot of surveys that we've been doing, right? And we're really trying to talk to homeowners out there in the market. So we surveyed over 600 homeowners in the industry and really trying to get a sense of like, is this resiliency thing really a thing? And of course, yes, we found out it definitely is, right? So 9 out of 10, the homeowners are considering this in their decision-making process, especially when they're looking at exterior products. And the top 3 things that they're thinking about is durability, ease of maintenance. And then on the far right there, those are some other terms that they're starting to throw around when they're trying to help go through that product and system selection process. So they're thinking about, okay, are these products impact resistant, wind resistant? Do I have a certified contractor that knows what they're doing?
I think there's an interesting marketing issue here that we found, and that is that previous homeowners appreciate this and understand this because they've had claims, they've had problems, they've had ownership, they understand the maintenance problem, right? So when they go to move to a move up home or an upgrade home or a luxury home or a vacation home, that's in their mind, and you can speak to them in a certain language because they have experience.
Yeah.
And then you have the first time home buyer that has never owned a home. You have to actually educate them.
Yes.
Because they've never owned a home. They've never had maintenance. They've never had a claim. They think all homes are the same, and they have no basis. So you almost have to have 2 marketing messages, depending on kind of whether you're dealing with that first-time buyer, really bringing them up to speed, or you're dealing with a repeat buyer who's already owned a home and kind of been through that once before.
All right, so what are the highest areas on a roof?
I'm glad you pointed to everywhere. Because that's my experience. Is that everybody's experience with the highest problems with the roof? Everywhere.
Yeah.
Every place you put a roof, that's where it's going to
Pretty
leak.
much.
That's my experience.
So roofs are the most exposed part of our buildings. Things to start to think about how wind shear hits a building. During a high wind speed event, wind's going to hit the side of that building face. It's going to accelerate up the face of the building. So similar to how an airplane wing works, right? It has to flow faster over that roof edge, which then creates a low pressure zone, which is actually what causes that uplift force right on the edge. So the edges of your buildings, so your eaves and your rakes, these are areas of a building that are getting exposed to the most amount of wind uplift force just based on how physics works. Your hips and ridges, right? So these are the other areas of a roof that are typically the first failure point during, say, a hurricane as well. So how do we think differently about what the attachment method is, types of products that we're talking through? So what I did, I tried to break this down into some different types of solutions in that green side of that, how they are addressing some of those issues that we talked about, right? So at the sheathing level, at the roof edge level, the actual roof covering itself, ventilation, the right side of the table, which is the implementation. So what are different types of building and installation practices that we can employ with our teams and our subs, or different types of products that we can choose up front that can start to address some of these issues? You don't have to do everything on a list, right? That might not be feasible from a cost standpoint, but maybe you can pick and choose some areas that then align with your region that you operate in, and that's That's how you start to improve that base system design. So this is looking really at wind resistance and water resistance on a building structure. As you're putting your sheathing down, right? Thinking a little bit differently on what that nail pattern is. So that sheathing experience that uplift force, right? And sheathing, if it's not fastened down properly, right, can actually pull up that roof covering system as well. So that could be an additional stress and adder on the roof covering. So thinking about, do we increase that nailing and fastener pattern? Do we change the type of fasteners down there, which helps to increase and almost double some of that nail pull resistance? Now that you have your sheathing down, what's next? Those small 1/4 inch gaps that can pour, tons and tons of water into the structure itself. So thinking about sealing up those, and there's different types of tapes and membranes that we can do to seal each one of those edges of that sheathing. And that's now going to start to create a much more watertight, water shedding surface. A best in class is actually looking at a full sheathing deck of self-adhered underlayment. So that's going to be an entire peel and stick. From the material side, right, the material might be a little bit more in terms of the implementation side of it, but long term, it's going to be a completely waterproofed in roof structure.
Some of the success we had again in marketing these features
Yeah.
was to be very explicit about this in the sales and marketing discussion.
Yes.
That says, look, here's what we do in our roofing system. We've added all of these features to our roofing system, and it costs this much.
Yeah.
So your home is $1,000 or $1,200 or $1,500 more expensive than the home down the street. Here's how much it will cost you to retrofit that home.
Yes.
Because the cost to you to build new is incrementally small. The cost for that homeowner to go and replace that system and do it themselves runs into tens of thousands of dollars. So it's a way to kind of value sell that says, you know what, I should spend a little bit more to get the home built right, because trying to build it right afterwards is horrifically expensive.
Correct.
And so it's kind of a marketing issue. We're always thinking it has to be the cheapest. It's because we don't value sell. And it is the issue of being very explicit. Look, we've added $5,000 to this home to build a better home. Let me show you where we did it. And let me explain, if you buy this home down the street, how much you're going to have to spend to retrofit that home to get the same effect. And it's going to be tens of thousands of dollars.
And one other thing too to think about is, I don't know what types of warranties you guys might be offering as well, but there's also that peace of mind that, okay, if you have a fully self-adhered roof deck, even if that roof covering, whatever material was chosen, fails,
If it doesn't matter.
that home is completely waterproof. And there's so much value in that.
2,500 square foot home, what's the cost for a builder to add some kind of self-adhering membrane versus a traditional underlay?
Yeah,
I mean,
I'll have to give a range, but depending on the region that you're currently at, right? So most regions, you typically do at least self-adhered on the eave edge, right? You're going to do one roll width and up valleys. So it's really, and that's probably 20% of the roof surface anyway. So say you're going to just do the rest of it. Maybe it's another $1,000, $1,500, maybe $2,000, depending on the material. Roof deck edges. So we kind of talked about how the wind shear works on a building, right? So sealing down those roof edges, typically most roof coverings have some form of a starter product, whether you're using asphalt shingles or metal roofing, but there is some form of a starter. But thinking about the asphalt side of it, historic asphalt shingles are typically fastened down and they're singular product units. There's new types of products out there that are fully self-adhered roll products. So from an installation standpoint, it's much faster for your subs and your crews. And also it's completely sealed down on that roof deck edge. And then on top of that, have an upgrade as well. Could be, okay, say your traditional 1.5 or 1.25 drip edge, maybe you add another 1/2 inch on that. So that an extra drip edge width can also help to kind of seal down that roof edge. So the ice and water shield is going to be fully self-adhered down. That'll go first on the sheathing. The starter product, so say it's a asphalt shingle, that'll get applied on top of that ice and water. But that's really where the first course of shingles then gets attached to. So having a full self-adhered starter product roll, which goes on top of your self-adhered, that's going to create a really good fastening point for your asphalt shingles.
I know when I started in first roofing, we'd use rolled roofing as the first course, just because it's fast.
Yep.
And the only problem is it came in 3-foot diameter, so you'd rip it.
Yeah.
Right? And you just do it, but it wasn't self-adhesive at the time.
Correct.
But what a great advantage. Take a rolled product, self-adhesive, just roll it out on the edge and then roof from there. That sounds like a great idea. It can't be much more expensive per square
No,
foot. It's kind of
no.
the same material,
Yep.
right?
And typically from an install standpoint,
cheap, faster.
it's much faster.
Way
So-
faster.
So, and one other thing to think about too is not just on your eave edge, right, but go up to your rake edge. So your rake edge experience really severe wind uplift. So putting that roll starter up that rake edge too now creates a full sealed in roof deck again for whatever roof cover that you're going to use. Lastly on this one, so from a ventilation, so not all ventilation is created equal. There are some ventilations that are designed to actually, resist that wind shear with the type of baffles that they incorporate in there, as well as a kind of channel baffle designed to help with water infiltration.
My favorite is when they use the 1-inch roof nails and they still use the ventilated roof cap, and it doesn't actually go into anything, and all your, cap shingles go
Yep.
flying off.
That's
Have you ever seen that?
I've seen that. So on the actual roof covering, right, sealing in that roof deck itself and getting it prepped for your roof covering. So from a resilient roofing standpoint, polymer modified shingles, these are kind of the next generation of asphalt shingles. What they do is they incorporate different types of compounded polymers that get mixed into the asphalt itself. So what it does is somewhat rubberized. During a hailstorm, that product can now spread out that impact load across the roof deck surface.
And then
So it
cover
acts-
afterwards.
Correct. And that's next piece is it's not just that durability during the storm, it's then after thermal cycling, that product will reform and reshape back to its original self. It's not just a hail product. And as we're seeing, the hail maps are starting to grow quite a bit as well. That different type of asphalt actually grabs onto the granules quite a bit differently, right? So granules are what keep the actual shingle there for the longevity.
And you
So
can tell
there's
the-
kind of an
And you
upsell.
can tell your homeowner they don't have to clean out the gutters as often, because what do you find in your gutters? All of your roofing you just put on your house.
So for some of us that might be in some wildfire prone areas, right? Fire resistant roof assemblies are critical to think about. So how do we design these? So firstly, I would say, think about what type of roof covering that you're going to be using. You could think about non-combustible roof materials like metal roofing, concrete tile, slate, but there are some, asphaltic products too that absorb heat as well. So while they might be combustible, their heat absorption properties are good.
There's some new underlayment that is kind of basically
Correct.
kind of fire
Resistant.
resistant.
Yep.
I mean, you can put a blowtorch on it for a half hour and it will just sit there and smoke.
So when we're thinking about the roof assembly, right, it's this trade-off between designing to code versus do we want to actually push the envelope a little bit. So from a roof assembly standpoint, putting down a fire-resistant self-adhered underlayment plus your roof covering, that's really going to be an optimal design. From a ventilation standpoint too, Darren kind of talked about this. Structure fires from a wildfire ignite typically in the attic space. So those embers that can float 20 miles from the actual wildfire itself infiltrate into your ventilation system. This is an area we have to think about. There's products out there that are WUI compliant, which is Wildland Urban Interface, and they have different types of actual stainless steel meshes built into them, and some have even other technology products that help to resist those embers from getting into your attic space. So lastly, I won't pretend to be an expert on this, but continuous load pathing is kind of that next step. So now that we have our roof system from the sheathing all the way up to your roof covering, how do we keep that entire roof onto that building? So continuous load pathing is typically more designed for new construction than it is retrofit, just because of the challenges of installing it. Getting those structural tie plates or different types of threaded connections from your roof to your wall assembly. So on the right-hand side, you kind of see those red plates and green plates, and then from your wall-to-wall or story-to-story connections, and then lastly, your wall-to-foundation. That now puts that wind uplift force, right, that's pulling up on your roof eave, and it puts that load all the way back down into the foundation. So how do we tie all this together, right? This is how it can look on a rooftop, right? So we talked about getting that sheathing down first. For number one, do you want to actually seal all those sheathing joints? I would say at a minimum, we all should be doing this. A best in class is actually using that ice and water shield that you see at the bottom. Number two, right? I would suggest putting that over that full roof deck surface. If there's one takeaway from today, that is a very large recommendation. Jumping to number four, right? So the starter shingles. So thinking differently about, are there self-adhered products that can roll across that full eave and up your rake edge? Number five, right? Picking the right roof covering for you in your area. So maybe it's certain type of asphalt shingles that have certain features in them. Maybe it's a different roof covering, but thinking about that ahead of time. So that's going to tie your roof system in. Number six, on the ventilation side, right? So thinking about Do you need a fire-resistant type of ventilation product? Should you upgrade your bare minimum? And lastly, your tip-and-rich shingles, which can cap everything off. We don't want to be designing to just the stressors that we're seeing today. We really have to think 20, 30 years out. And how do we incorporate, even if there's small changes into our practices today, to really try and change that calculation for these home buyers so that they can be happy in the long run.